Hello students, welcome to Wallah English channel. In this session, we'll be continuing the PDA topic, which is DCFLs and CFLs. Now we are going to look at how to identify context-free languages and deterministic context-free languages. If we look at the previous sessions of the push-down automata, we have understood how to construct the PDA, and we have also seen that what is the difference between DPDA and NPDA. Okay, so in this session we'll be covering both again, the DCFLs versus CFLs. Okay, let me start the session. In this session I will be seeing DCFLs, CFLs as well as CFLs which are not DCFLs and not CFLs, some practice questions at the end. Yeah. Okay, how to identify the CFLs and DCFLs? Yes, good evening, Sima. Mute. Yeah. Basically, how do we identify CFLs and DCFLs? You want the CFL, then you should know that either PDA exists or you should know context-free grammar exists. But for that, you should understand the non-deterministic behavior of the language or machine. And for DCFLs, you should know there is a deterministic PDA, and that's the most, because the special grammar that we don't look at here. In compiler, you have the LR grammars, but we don't take any kind of grammar to understand DCFLs except the knowledge of deterministic PDA. Okay. Now let's begin the languages. How do we identify? Let's look into the language. Suppose you have a language. You already aware of the regular and non-regular, right? The first, the target is you should know, is it regular or not regular? Then only you can go further to understand whether it is DCFL or not. See, every regular we already know it is DCFL, so we can call it as CFL. So no need to worry. If the language is regular, that means by default it is DCFL as well as CFL. But when language is not regular, it could be possible DCFL, or it could be possible which is not at all DCFL. In case if it is DCFL, it has to be CFL. No need to worry about. And in case if it is not DCFL, possible that it may be CFL or it may be not CFL. Okay. So these are the classifications that we are going to look at in this session. Now we have the languages, some regular, some non-regulars. Every regular DCFL as well as CFL, but non-regulars are two types again, DCFLs and not DCFLs. If the language is DCFL, then definitely CFL, don't worry about it. If the language is not DCFL, possible that it may be CFL or it may be not CFL. Okay, so every type of the language we have infinite examples. If you ask me how many examples are there here, infinite here, infinite here, infinite, and every place we have infinite examples. Okay, one example I'm going to write here. In this you get a finite and infinite both, because regulars are two types here, finite and infinite. So I'm just giving one example, A star, B star. So this is a regular, DCFL, CFL, everything satisfies. What about a DCFL and CFL but not regular? Example, A power n, B power n. It is not regular, but it is DCFL as well as CFL. And CFL, but which is not DCFL. In that case, you already seen one example, W power R, where W belongs to A or B whole star. Okay, if this is a language, then it is called as CFL but not DCFL, exactly same, W power R. And if it is not a CFL, and also it is definitely not DCFL, not regular, if you look at it. So very simple example, you have A power n, B power n, and you can take one more A if you want it, A power n, it works. A power n, B power n, A power n, or A power n, B power n, C power n. If you want to take only over A's and B's, and this example would be sufficient. If you want to take 3 symbols, then A power n, B power n, C power n. So this example is going to be not CFL. Okay, let's see some of the examples to understand what language it is. Okay, let's practice some examples. The first example. Suppose I ask A power prime. You know, this is not regular, right? What is this language? It is not regular. We know it is not regular, but it is also not DCFL. Not only that, it is also not CFL. This language, we do not have a PDA. For this language, we don't have DFA. We don't have even DPDA. Especially if the finite are not able to do, PDA cannot do if the language over one symbol. So language over one symbol, there is no difference between the finite automata and PDA power. So PDA and finite automata both are equivalent when the language is having one symbol. So language should be either both regular and CFL, or it cannot be both. So that's a very important point. When you have over one symbol, that only A's are there in the language. In that case, it is finite automata and PDA both will have equivalent power. Okay, that's the first point you should know about the difference between the FA and PDA over one symbol. The second example. When I take A power n, B power 2n, you already know about this language, right? You already know about this language. It is not regular. Why it is not regular? Because we don't have finite automata, we don't have regular expression. So many reasons why. And second, it is DCFL. It is DCFL. And hence, no need to write it is also CFL and so on. You know that. So once I say DCFL, it is definitely CFL too. So this is the most important point. It is DCFL because you have a DPDA. How do you know it is a DPDA? You have a DPDA. You already constructed. Every A you can push 2 A's and every B you can pop 1 A. So you have a logic deterministically. That's why we have a DPDA here. The stacks you are able to use the operations deterministically. Every A push 2 A's and every B pop 1 A. So that at the end you see just Z naught on the stack. It means you got accepted A power n, B power 2n. That is the machine I am speaking. So here, whenever you want to say DCFL, the whole logic of DPDA should be there in your brain. Okay. Let's move to the third example. A power n, B power n, C power n. Very famous example. And this is, we know it is not regular. The reason behind it, you know it is because there is some dependency between the symbols and n is not given. So it is by default starts with 0 here. And it is also not CFL, not DCFL, not CFL. The reason is we don't have even PDA for this. So one stack not enough to understand this problem. You give me any string from this and there is no PDA that can accept every string from this language. Okay, so there is no PDA for this. That's why just saying this word is enough. When you say not CFL, by default you are also using these 2 sentences. Okay, so it is very famous language which is not CFL. Fine. The fourth one, A power m, B power n, C power m plus n. So this language where m and n are greater than or equal to 0, this language is not regular. The reason is you have some dependencies between the symbols and that comes till infinite. Okay. Now A's using stack you can understand. A's you push, B's also you push, then C's you pop the B's first, and when the B's are over, then pop the A's. And where the end of the input, then nobody should left on the stack. Z not only there on the stack. That means the string is in this form. So now deterministically you are able to understand this problem. That's why it is DCFL. See, before saying DCFL, we are trying to look at how do we perform any operation on the stack by looking at the symbols. Deterministically we are able to do it. There was no confusion on any symbol when you are reading it in this sequence. A's you push, B's also you push, every A 1A, every B 1B you push, but every C first you pop the B's, and when there are no B's and when the C's comes, then pop the A's. If you do this, at the end you will see only Z0 on the stack. When the control reaches to the end of the input, then stack should have only Z0. So this is the whole logic of DPDM, right? So this is a DCFL, hence you can call CFL too. Okay, the fifth one. And any language you take over one symbol, especially like a power n factorial, it is not regular, so directly you can say not CFL. So now indirectly I answered, it is a not CFL, not DCFL, not regular. So one statement is enough, not CFL. When we say not CFL, it is always not DCFL and not regular. So keep in mind, so if anybody says regular, it means DCFL and also it is CFL. But anybody says not CFL, it implies, even not a DCFL, it also implies not regular. Okay, you see this statements. Yeah, Tanuj, good evening. When you see the statements, right, every regular is DCFL, every DCFL is CFL. And same way, every not CFL language, that every not CFL is not DCFL and every not DCFL also not regular. So you can use these two implications. They are very important here. There are two implications. Here, no need to write everything. Just write not CFL, indirectly you answer other two also. Okay. The sixth one. There are very famous languages like WW, such that W belongs to A comma B whole star. If you have studied the regular languages, we know this answer is not regular. We know there, because we cannot design a DFA for this. WW concept over more than one symbol is difficult. Now, other thing, can you design a DPDA? Can you design a PDA? See, W when you push, right, this W is looking in the queue form, like it's not a stack order. So WW power at least you can do using non-deterministic operations. But here, this has never been the stack order. WW, which looks like first in, first out. So W, if there is the symbol like, let's string like ABB, then same W should come here again. That's ABB. So in case if you push this onto the stack, this A will be there in the bottom, but that you are expecting first, that is not possible on the stack. Okay. So anyhow, this, you know, it is not a regular, it's not a CFL, also not DCFL. Okay. It is a very famous language in not CFL. Okay. But this is context sensitive language. All the language that we have seen here, context sensitive so far. Okay. Even it is not a CFL, Raviteja. It was not a CFL. Don't say NCFL also. It is not CFL. Okay, NCFL means CFL, remember. NCFL represents CFL. 7. In case if you have W hash W power R, we have already studied this. We have already studied this. What is the language? What is this language? Is it regular? We know it is not regular because there is some kind of dependency between the two positions here. It is a not regular, but it is DCFL. We have seen in the previous session, we have seen DPDA for this. So definitely a DCFL, hence it is a context free language. Okay, no need to write CFL because we know it. It is a deterministic context free language. It is deterministic context free language. Every symbol in the W first push, when hash comes, skip, but remember that later you are going to match the symbols. Yeah, pop afterwards by matching. Yes. So this language we have already done in this class itself. Okay. Now this is very special, W hash W. It's a very famous in programming language. The concept derived from this language is like the first W represents the declaration of a variable, the second W represents use of variable. So hash is something else that you don't worry about it, and WW, there are two times W coming. So in programming language there is a concept behind it. The first W represents declaration, the second W represents use of that variable. So declaration of a variable, use of the variable, same variable is coming twice, and this language can help you to understand the that semantic of the declaration and the use of a variable. Anyhow, don't worry about it. So what is the meaning of this? Is it regular? No. Why? Because there's some kind of dependency there between two positions, and that comes forever. And is it a DCFL? No, because stack cannot understand this problem at all, and hence it is also not CFL. Okay, hence it is not CFL, and there is no logic to understand with one stack. There is no logic to understand with one stack. If you have two stacks, yes, you can do it, but with one stack you cannot do it. That's why it is not CFL. Nine. A power n, B power 2n, C power 3n. And again, all the three symbols are depending on each other. See, if I have 100 A's, there are 300 C's. If I have 100 A's, there are 200 B's. So any symbol you give me the count, then other two symbols count can be derived from any symbol count. That means all the three are depending on each other. So you cannot compare only two symbols, because the stack can help you only to compare the two symbols, but here three symbols you want to compare parallelly, right? So that makes it is not CFL. What is the answer? It is, you don't have a PDA for this. In fact, you don't have DPDA, you don't have a DFA for this. Yes, with two stacks you can do that. Even this problem also can be solved with the two stacks. How can you do that? A power n you can push on both the stacks, then B you can compare with one stack, C you can compare with other stack. Indirectly you compared all the three somehow. Okay. Okay, 10. Let's practice this problem. W x W power r such that W comma x belongs to A comma B whole star. So take the time and look at what language it is. If you have remembered how to identify regulars, this language was already answered. Any answer for this language? Is it regular, or is it DCFL, or is it CFL, or is it all? Oh, that is a mistake. That's why it's not it's not that, Raviteja. This was already answered. It was a regular. It is in fact simply A plus B whole star. We have solved this question that W was a repetitive, so you can put epsilon there, so then X you can get everything. So when you put W epsilon, then reverse also epsilon, then X you can derive anything that you want, because X is not depending on anybody here. So this is actually A plus B whole star. You give me any string in this, I have here. So this is actually having all strings in the world. Only you should realize how to get them. Okay, so this is a regular. I have explained there itself, why it is regular. Why it is regular. Once it is regular, no need to talk about DCFL, CFL, right? It is. If you want to generate AB, how do you do it? Just do one thing. Put W is epsilon, then put X is AB over. You give me anything, I'll do the same way. Whatever you give me, I'll put that is X, and W is always I put epsilon. When W is epsilon, you get every string in the world. Remember that. Over A comma B, you will get every string. Always put W is epsilon. Even it is not. Somebody, somebody given something like this. W is A and X is, let's say, BB, and you get a string like A, B, B, and reverse is A. So even somebody given this, you just make it like W is epsilon, X is nothing but A, B, B, A. That's it. You get the same result. You get the same string here. After putting in W, X, W power R, you get the same string, right? But you might do this way or this way, doesn't matter. Always you can prove with the W is equal to epsilon. So even W is, your assumption, W is A. So W, X, W power R, you got A, B, B, A. And the same string you can get some other way. W is epsilon, X is this whole string, and you got that W, X, W power R. So any string in the world you can get with the help of W is epsilon, and so hence reverse of the W is epsilon, X, what you want to derive, that you can put in the X. Okay, is possible. Okay, similarly, there are many languages that we are not worried right now. W power R X such that W comma X belongs to A comma B whole plus I'm doing. If I do whole star, it was already regular, but this time we know it is not regular, because now you cannot say A plus B whole star, because you can't generate everything here, because at least one symbol is there in W power R and X. So minimum length is 3 here. You can't get epsilon from here at all. And is it DCFL? See, W power R X, in that everybody is there, and this thing deterministically impossible to understand when the reverse of the W begins. So it is not DCFL. If ash is there, something like, okay, I'll just write in the second example. If ash is there, you may do something here, but ash is not there, and it is CFL in fact. Why? So you can push this one, you can start popping, and this one you can skip simply. No need to do anything with that remaining symbols, but at least one symbol should come here. And this is a CFL but not DCFL, and also but not regular. And now look at the same problem. Small changes here. W ash X, or you can write W power R if you want it. Ash X. Now this time when you put a plus, but because of that ash, you got a deterministic logic. You push, and now you clearly know when the reverse begins, because this ash you are going to skip. After that, definitely this comes, and now you need to pop. Previously push and pop, that you don't know when you need to do in order, because here there was no special symbol to separate them. Now we have ash, so that now I know I can start the pop by matching with the reverse of the W. Now then this ash will help us to understand the remaining symbols. We do nothing, just ignore them, skip them. You got a clear logic. When to push, when to pop, when to skip, without any confusion. And the language is definitely not regular, because you need a stack to understand. It is not regular. And what about the DPDA? Do you have a DPDA for this? Just this, whatever I have mentioned, right? You can design a DPDA. So it is DCFL. Now no need to talk about CFL, because every DCFL is a CFL, right? Everyone? Okay, let me give you some questions to understand, or you can try. Okay, you can try. So before that, let me give some questions here. How many we did? 12, right? So remaining I will give you time, so you try to solve them. 13. A power n, B power n square. 14. A power m, B power n, C power mn. 15. A power n, B power n square, C power 2 power n. 16. A, B power n such that m not equal to n. 17. M less than n. It's a less than or equal to. M is equal to n or m is equal to 2n. Let's see how do you answer it. Yeah, Prince, I can see you. Yeah, Seema, need to practice. Not that easy, right? Need to put a lot of effort to construct the PDA. Because finite you may understand because everything you see in the state, but in PDA there is a stack behind it. Unless you understand the stack, will be difficult or will be taking time to understand. Okay. If I know exactly what problem you are facing, I can handle it. But still you don't know how to construct the PDA, then really very difficult for me to explain where you are having difficult. Yeah. Non-regular is not the right answer. I want to find out exactly what is the answer. Is it CFL or DCFL? You need to go till the right answer comes. If it is not regular, not DCFL, not CFL, then answer it simply not CFL. But saying non-regular, I don't know whether it is DCFL or not, CFL or not. So answer it exactly. What is the best answer? Non-regular may be right, but what is the language? Is it DCFL or CFL? Right, you are missing that other points. That's why I used to answer all the possible things. I did not stop at not regular. You look at the previous examples. Take time, 2 to 3 minutes. Then we will start solving it. Per 14, 15, yeah, correct. 16, CFL. You forgot DCFL concept? This is in fact DCFL 16. 15 not CFL, correct. Tanwar. You're right. Sugandha Tanwar. Yeah. So when somebody is asking about the language, you should know the experience in constructing PDA and DPDA or understanding the CFLs and DCFLs. The most important one, how you answer it. Yes, Raviteja, it was DCFL also, right? Then why are you answering CFL? So answer DCFL, I will know it is a CFL. But when you answer CFL, right, how do I know it is DCFL? So I want the best answer that can match remaining all. Okay, first one, n square concept is impossible using the stack. So the n square concept, you cannot understand 2n, 3n, 100n, you can do at least. But n square, this concept is not there in stack at all. So not CFL is the best answer, because not CFL means it is not DCFL, not regular, everything I have answered. So not CFL is the best answer for the 13th one. Okay. 14th, that mn, multiplication of two counts. See, sum of two counts you can do it with the help of stack, like m plus n, c power m plus n. We can do it because that's possible, but multiplication is not possible with the help of the stack. It's again not CFL, means not regular, not DCFL, and answered it. Now 15, the same concept here. Already n square I was not able to do, then 2 power n is obviously, when you take one symbol also you don't understand 2 power n with the help of the stack. So this is also not CFL, the best answers. But this one, m not equal to n, m not equal to n, it means it is m less than n or m greater than n. So this can be done deterministically without any confusion. See, when m less than n happens, right, there is more b's happens. What happens here? When more b's are there, then many b's left in the input. So those b's, you are going to skip them once you pop all the a's. So many b's left after popping the a's. So when the b comma z naught comes, you are going to start ignoring or skipping all the b's till the end. So till the end. So this can be done. And another one, if a is greater than b's, then what happens at the end of the input, a's will left on the stack. So both can be understood without any non-deterministic stack operations, pure non-determinism. So this is deterministic. So you may call it as non-determinism, that's fine, but it is deterministic context-free language. But it is not a regular because you have some kind of dependency. DCFL is the best answer. So answer to CFL, right? No need to say CFL right now because you know it is CFL. Now another one is also same, m less than n or m equal to n. If it is equal, at the end z naught is there on the stack. If it is b's more, then at some point of time b comma z naught happens, then that time you need to skip all the b's and then go to final. Okay. So this is also DCFL. And another one, this time you see the 18th, a's equal to b's or a's might be twice to the b's. It means first a's you may push, but b's what you do? 1b, will you pop 1a or 2a's? Here you have a confusion, but with a non-deterministic choices you can do two paths. One path you take m equal to n, other path you take m equal to n. Yeah, you may try that, Sima. You may see the answer, but seeing the answer not enough. Understand completely for every transition that you have taken, and if really you believe that that is motion is correct, then cross check and do after looking at the answer. That's fine. For a beginner, yes, you should do. As when I was studying, really I don't know how to construct the PDA, right? But today I am able to teach it because you need to know exactly how to understand. At this point of time, for many people, not for you, many BTech students, constructing PDA is not at all easy, but many who are going to make it easy, they can understand the better in GATE syllabus. So it's very important, every topic you need to go a little bit understanding level, then try someday definitely, or sometime after you will understand. When you don't get, then discuss with someone how are you able to understand. So this is very important in at least GATE preparation. In semester, if you don't understand, you don't write, or you may sometimes remember and write, but here remembering will never work. Before remembering, first you need to understand why these languages are DCFLs and CFLs. Do you have a proof first? What proof you have? Whenever it is not CFL, definitely you don't have a PDA, but whenever you have a DCFL, you can design a DPDA. First learn what is a DPDA for this. If you are able to design a DPDA for this, right, you will never ask the question why it is DCFL, because you have a DPDA for this. Okay, and this one, there is no DPDA for this, and for this you can design a PDA. That's why it is CFL, but remember it is not a DCFL. For that, how do you know it? You can only get a PDA, you will never get a DPDA for this. So by understanding the construction, you can easily answer this question, that is CFL but not DCFL. Okay, so let me ask you some questions for this session. Okay, The question 1, I will give the language, just you need to identify, but I may give you a different language right now. Okay, you need to identify this language, which I did not give you. Okay, see, A power n, B power n, union, it is a one language only. Okay, it is a one language only. Don't assume it is two different languages. It is just one language, L only. And now you need to find what is this L is. Is it regular? Is it DCFL but not regular? Is it CFL but which is not DCFL? Is it not CFL? Just choose which one is right. Okay, I hope you can easily answer this question, but before that, understand, if the string comes from this language, do you have any deterministic transitions in a sequence? That we will see tomorrow, Ravi Teja. If A is CFL and B is CFL, R means what? Is it union? What are you trying to say? Is it union? A or B? What do you mean by A or B? Is that A union B? We can do it. So union is a CFL. Yeah, that closure properties we'll do tomorrow. Okay, in this session, just focus on languages. Okay, focus on languages, nothing else. The same kind of language I'm taking now, but switching something different. Same options you take always, regular, DCFL, but which is not regular, none are not CFL, anything is fine. Okay, now the third will give you something different. Maybe this first two, 1 and 2 might get the same answer, but third is very, very important for you. Now the C is not before A, not in the middle, but it is at the end, and that makes a difference. Now A power m, even D is also I am taking here, that is at the end, so this makes a difference in the answer. So previous two and this one you can compare later and understand what is the difference. DCFL which is not regular, CFL which is not DCFL, and then not CFL. Yeah, when you can make a PDA CFL, but also look at making a PDA is not enough. You may make a DPDA. If you are able to make a DPDA, it will be DCFL, right? So Ravi Teja, you should be very clear. You need to look at from finite automata. If not exist, then go for DPDA. Not exist, then go for PDA. Don't directly go for PDA. It might exist, but still DPDA might exist. Yeah, exactly, Ravi Teja. When you can make a DPDA, yes, you are right. It is a DCFL. It is. Question 2 is different from Q1, but almost the concept is similar. Whether C and D comes in the first or in the middle, you don't have much difference. You do the similar logic. But when they come at last, you will have a little bit confusion. Here, see, A's you push, but when B comes, don't know what should I do. Is that string or this string? You don't aware. So now you need to take a non-deterministic. But previously, C and D were helping. C is there in the middle. At least C comes before B's, then I know exactly that is equal A's and B's. If D comes before the B's, then I know B should be twice the A's. So now C, D are not the before the B's, or not before the A's, then you are having an issue here. You are having confusion here. So here you don't have a deterministic PDA, but you will have the non-deterministic PDA anyhow, that you try to answer it. Okay. Okay. This question 4 might be easy, and just you need to understand what strings you have here. Is actually, it looks like a power n b power n fashion, but what I did is just, I've written twice, but you can make a very simple one. Don't say it's a regular. Okay, it's not a regular, it's something different, right? It's you are going to get a power 3 and b power 3n, so something which is not regular, okay. And this one is different, a power n, now let's say b power 2n, now again you have written a power n, now again you have written, let's say, b power n. So this is something different, okay. Both are, this one and previous one completely different. This one you don't have even DPDA, you don't have even PDA for this. Okay, try to understand. Okay, I'll give you different options now, DCFL, CFL and not CFL. Okay, try to choose the best answer which is possible. Okay, so for this question you do not have a PDA at all. Yes, context sensitive language, which is correct. For this question it is the correct context sensitive, but which option is right according to your statement? Okay, in this session I have tried to explain how to identify the languages, but really you take, previous gate PYQs and try to practice. In the coming sessions we'll see, in the practice session, look at some examples. We'll look at some examples that what are the gate PYQs we have. In the next session we'll be seeing the closure properties, then we'll go for some practice session. There we will be knowing exactly, what kind of questions that we are coming in the exam from this chapter. Okay, thank you so much. Bye bye, see you, take care.